Where is everybody? So wondered the great physicist Enrico Fermi. The universe is ancient and immense. Life, he reasoned, has had plenty of time to get started and get smart. But we see no evidence of anything alive or intelligent in space. In the last few years, we have discovered planets in the habitable zone of stars, which are quite common. And based on the numbers discovered so far, these are estimated to be billions in our galaxy alone. Yet, we are still in the dark about life. Are we really alone, or are there others out there? It's one of the biggest questions, and only science can answer it. So BITM, along with the Royal Society of Chemistry, Eastern India section, welcome our live and remote audiences to today's discourse on scientific search for extraterrestrial life in the 24th Niroprova Memorial Lecture, The Elusive Aliens. The biggest questions of our existence are at stake today. Are we the universe's only child, our thoughts its only thoughts, or do we have cosmic siblings? To untangle this mystery, we have with us our distinguished speaker. I would request Curator BITM, Srini Apikonda, to please welcome him with a small felicitation. I would request our audiences to please join us in welcoming Professor Sujan Sengupta. Can we have a round of applause for him, please? Professor Sengupta is a senior professor, Indian Institute of Astrophysics, Bengaluru, and visiting professor of physics, Ashoka University, Sonepat, Haryana. I would request our audiences in the demo hall to please join us in welcoming him, and we look forward to learning from you, sir. Before we engage in this session, I welcome to the podium Curator Srini Apikonda to deliver his welcome address. Over to you, sir.
Respected Professor Sengupta and other dignitaries over the dais, teachers, and my dear students, on behalf of BITM, I welcome you all for this lecture session. As you all know that BITM happens to be the oldest science museum in the country. We have been popularizing science since 1959 through various ways, and one of the ways is through lecture sessions. So, if you see one of the trending topics or interesting topics in current times, I think life in other planets happens to be one of the interesting topics, as we know. So to enlighten us, to give some interesting insights, and we are happy to have today with us Professor Sujan Sengupta. So he will obviously, give us some interesting insight to know more about the, life in other planets. So with this welcome note, so I would welcome you all for this lecture session.
Thank you, sir. Today's session will not have been possible without the initiative and generous support of the Royal Society of Chemistry, Eastern India section. So please join me in welcoming Dr. P. Jaishankar, President, RSC Eastern India section, to introduce us to the missions and objectives of the Society. Over to you, sir.
Good morning, everybody. Respected Professor Ashish Dey, Advisor, Royal Society of Chemistry, and the immediate ex-secretary, respected Professor Mukul Basu, immediate President of Royal Society of Chemistry Eastern India section and advisor, Professor Manas Chakravarti, Immediate Vice President, Right Society of Chemistry, East India Section and Advisor. Respected Professor M.K. Poddar, Vice President, Right Society of Chemistry and Advisor. And Sri I.K. Mukhopadhyay, former Director General, NCCSM. Respected Professor Sengupta, today's lecturer, and we are all eagerly looking forward to your lecture, sir. Respected Sriparna Datta, Treasurer, IIT Society of Chemistry, East India Section. Professor Sangram Bagh, Honorary Secretary, IIT Society of Chemistry, East India Section. And Professor Suman Mukhopadhyay, Treasurer, IIT Society of Chemistry, East India Section. And Professor Mr. S. Apikonda, Curator, BITM, Director, BITM, and all the officials of BITM. Without the constant support, it would be impossible for Right Society of Chemistry East India Section to organize such an event. On behalf of the Society, it's my pleasant duty to welcome all of you, and I thank you all your participation with the enthusiasm. And as I was telling that it would be impossible for Right Society of Chemistry to conduct such a big event every time. This is probably the second big event which is being conducted in this auditorium by Right Society of Chemistry jointly with the BITM, without the support of BITM. So we feel that I think it's a kind of conglomeration between Right Society of Chemistry and BITM. So I would like to thank on behalf of the Society to the BITM officials, director, and everybody who is contributing to this great event. So the Right Society of Chemistry Eastern India Section has been serving to the scientific community in the form of disseminating the information, taking the science information to the doorstep. This society, we all know that actually the mission of the society is that to propagate the science, especially chemistry and chemical allied sciences. And of course, without physics, chemistry would be impossible, it's unfulfilled. So, every year, this society is organizing seminars, scientific seminars, memorial lectures, science exhibition, etc. So we have been able to successfully conduct very recently, maybe last week, in University of Burdwan, a science seminar. And earlier, we conducted here in this auditorium a science seminar for the schools, for the state of West Bengal school children, wherein all participated actively and won the prizes. So these are some of the activities which the society is involved in disseminating the information and giving the hands-on training wherever it's possible to them to test the science and infuse the scientific temperament among the students. That is the main purpose of this society, and we will be continuing to do that. And today's lecture is going to be something which is very unique. And when I talked to ex-DG, he told that, thank you very much, sir, for coming here. He said, the topic is such thing which I could not resist myself with not coming to BITM. So you are all looking forward to this excellent topic, and I would like to thank the seniors and the advisors of the Right Society of Chemistry for giving such an opportunity for us, entrusting on us. The new committee has taken over the charge, and definitely, sir, we will be able to fulfill your expectations. Thank you all your participation, and have a nice day. Thank you.
Thank you, sir. To introduce us to the importance and background of the Niroprova Memorial Lecture, I would like to welcome to the podium Professor Shri Parnav Dotto, Royal Society of Chemistry, Eastern India Section. Over to you, ma'am.
Niroprova Memorial Lecture is being organized by the Royal Society of Chemistry Eastern India section for several years, and it is in the memory of Srimati Niroprova Banerjee, who was the wife of Dr. Dashruti Banerjee, the father figure in rubber technology. She was born in 1920 in Midnapur, but unfortunately she lost her father at a very early age, and she came to Kolkata and stayed with her maternal uncle, Professor J.L. Banerjee. After schooling, she was married to Dr. Dashruti Banerjee. She was a lady with a golden heart. She supported many needy students who ultimately were established in their life, and she also helped her husband in his activities. She went for her heavenly abode in 1996, and from 1998, Royal Society of Chemistry Eastern India section started the first Niroprova Memorial Lecture, which was delivered first by Professor Dipankar Chakraborty, Director of Indian Association for the Cultivation of Science, and many other academicians and scientific personality thereafter delivered this lecture, like Professor Deepti Kumar Chattaraj, Dr. Prashant Kumar Ghosh of DBT, Professor Shomir Bhattacharya, Director IICB, Dr. Shakti Pada Banchodhuri, Professor J.J. Ghosh, and many other personalities. This is the 24th Niroprova Memorial Lecture, which has been organized by the Eastern India section of Royal Society of Chemistry, and it is being delivered by Professor Sujan Sengupta. I hope that all the students present here will learn many things as well as enjoy the lecture. Thank you very much.
Thank you, madam. To delve into the nuances of cosmic concepts, we have with us a stalwart of astrophysics. May I request Dr. Shongram Bag, Secretary, Royal Society of Chemistry, Eastern India Section, to introduce today's speaker to our audiences. Over to you, sir.
Good morning, everybody. This is my pleasure to introduce Professor Sujan Sengupta, who is the Senior Professor at Indian Institute of Astrophysics, a premier. And Indian Institute of Astrophysics is a premier research institute of astrophysics in India, and I hope one day who are going to do the research on the astrophysics, some of you may actually end up at Indian Institute of Astrophysics, Bengaluru. So Professor Sujan Sengupta is like he made some pioneering contribution to a polarimetric method to detect some of the exoplanets and its characterization, along with the brown dwarf. So, and his methods throughout the world, people use to search for exoplanets. Now, in 2015, Yuri Milner actually developed or established, which is something called Breakthrough Initiative Project. So if you go to their website, you'll find the goal of that project is to, a fundamental question of the science, are we alone in the universe? To develop that initiative, there are many people who actually signed a particular document that this problem is very, very important and we have to go for research. And those people are probably you, Stephen Hawking, all of you know, Professor Keith Thorne, I don't know if all of you heard of it, but who got the Nobel Prize. He's one of the living legend of the physics at our time. In 2017, who got the Nobel Prize in physics. But another popular aspect of Professor Keith Thorne is, if you have seen the movie Interstellar, and that the scientific consultant of that movie is Professor Keith Thorne. and he was also a producer of that with Christopher Nolan. So, and in that signature, there's one of the signatures is from Professor Sujan Sengupta. So, Professor Sujan Sengupta is also worked as a visiting professor. Many institutes like Academia Sinica in Taiwan, and he's also the member of International Astronomical Society. At the same time, he wrote, other than his research, he actually wrote some books, and one of the scientific book he wrote in English, like about finding these exoplanets, and one of the Bengali version, which is published by Ananda Publishers last year, we can actually see that book. So one important thing I believe that we always are excited about aliens, right, from our childhood. I always have a question that if there is an alien among us, which is in the human form, how to detect it? From a nice childish question. But this is probably the first time in my life I'm trying to get some answer from someone who is really researching scientifically to find the life signature beyond our Earth. So, I welcome Professor Sujan Sengupta, and now I think we can go directly to the lecture. Thank you.
Thank you, sir. We'll just take a little time to clear the settings. Sir and madam, please take your seats in the audience while we set up the stage for the speaker. Audiences in the demo hall, in the remote location, can you hear us properly? Yes, Loreto Elliott Road, can you hear us? Could you please raise your hands if you can hear us, Loreto Elliott Road? Very good, thank you. And Kamla Chatterjee School for Girls, you can hear us? Very good. So, you are there with us, just not physically present, but we are connected to you, and we request you to take equal participation in the lecture. Enjoy the lecture, and at the end we might have an interactive session with the speaker himself.
Hello. 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 I'm volume to music. Hello. Hello.
Let's welcome Professor Sujan Sengupta on the dais with a big round of applause. He will be speaking on the Elusive Aliens, a scientific search for extraterrestrial life. Over to you, sir.
Thank you. First and foremost, my respect to the late Niroprova Banerjee, on whose memory this lecture is scheduled, and then my thanks to Dr. Sangram Bagh, Dr. Jaisankar, Dr. Siporna of the Royal Society for Chemistry, who has invited me and who has extended the local hospitality. So thanks a lot. Now, BITM has a solid contribution in shaping my career and life in my childhood. So when I was in class 7, I think one mobile laboratory visited our school, my school at a rural town in Purulia district. And the person who was there, that he performed about 20 experiments in our classroom, and that was awestruck. Means I was really mesmerized by those experiments, and for the first time in my life I realized how science works, and that influenced me a lot to go for science. Then when I was in class 9, there was an eloquence competition organized by BITM all over India, and I represented my school, that was Southeastern Railway Boys High School at Adra, Purulia. It was under the region of Raghunathpur, and I stood second in that eloquence competition in the region. And BITM gifted me a book whose name was Paramanu Jigyasa by a famous scientist at that time, Dr. Shantimay Chattopadhyay and Enaki Chattopadhyay. And when I read that book, I was really impressed and decided that no engineer, no doctor, I want to become a scientist. And then I was influenced, decided to become a nuclear physicist, but then some other thing also influenced me. For example, Manusher Jonno, Jivan Jonno, so I decided not to go for nuclear energy or atom bomb, but instead of that, I will become Amiya Jajabar of the universe. So BITM has a very influence on my career because of that motivation, because of that book. In fact, I wrote a letter to Dr. Shantimay Chattopadhyay, and he replied to me also, and all those motivated, and that was because of that book was gifted by BITM to me. I still keep that book, is there with me, and the letter by Professor Shantimay Chattopadhyay. So my heartfelt thanks to the BITM. Still so you have a contribution for what I am now. Now I know all of you are aware of extraterrestrial intelligence or alien. Many of you may have started believing in the presence of alien on Earth by seeing photographs, videos of wild animals or UFO that suits our imagination. But science is not based on belief or faith even of the majority of people. Science requires unambiguous evidences, and the testimony of eyewitnesses is never considered an evidence. Now, for the last 6 decades, we have tried our best to find out any signal, any signature from outside the Earth or outside the solar system, but we are still, the alien or the such type of signal remains elusive. Now, during the next 45 minutes or 1 hour, I will tell you why we still could not find out any signal or any signature that may be associated with extraterrestrial life or extraterrestrial intelligence. That's Earth. That's our home. That's where we live in. But during the 4 billion years of the evolutionary history of life on this planet, Our oldest ancestor, the Homo habilis, appeared about 2 million years ago, and our species appeared about 300,000 years ago on the earth. Cultivation started 10,000 years ago, and the first urban civilization started about 5,000 years ago by the Sumerian civilization in Mesopotamia. So, but all these earlier civilization people, they were aware about some wanderers on the stars, and they also imagined that intelligent life exists outside the earth. In fact, the ancient Greeks, the Chinese, the Indians, all they thought that God and Goddess, that is the superior of the human, they lived in the stars and the celestial objects, and they teach us, the human being, about their civilization, about culture, about technology, about arts and all those things. But about 2,500 years ago, the Greek philosopher Aristotle, he sort of imposed his own idea that Earth is a special place and it is the center of the whole world. And then the Roman Catholic Church, after 1,000 years of, after 500 years of Aristotle, has decreed that there is no knowledge beyond Aristotle, and any opposition of Aristotle philosophy will be against the religion. And the Roman and the Greek emperor also supported, and therefore for 2,000 years there was no progress in science. But many scholars, they realized, when more and more evidences were gathered, they realized that actual universe or the actual world outside the earth is not matching with the Aristotelian concept. Finally, in 1547, Nicolaus Copernicus, a Polish astronomer, he wrote a book just a few months before his death, and he proposed that actually sun is the center of the whole world, and he considered that not only all the planets and earth, but also all the stars, galaxy, everything whatever we see, that orbits around the sun. So it has become a heliocentric universe with Copernican theory. So immediately after Copernican proposed it, Giordano Bruno, an astronomer and philosopher and poet, he then told that, he just realized that if sun is the center of the solar system, and if all the stars in the night sky we see it are similar to the sun, then there must be some planets. They also have similar type of planets, and some of them should also have a similar planet like Earth, and some of this Earth-like planet may have life. Then there was Tycho Brahe who gathered a huge amount of data on the motion and the position of the celestial object. By using Tycho Brahe's data, Johannes Kepler derived the 3 laws, that is we know as Kepler's law. So for the first time, he told something else, that the planets are orbiting not in circular orbit that was thought by Aristotle, but in elliptical orbit. And then Galileo Galilei didn't invent the telescope, but he used for the first time the telescope to watch the celestial object, and he discovered the 4 moon around the Jupiter. And so it was proved that not everything rotates around the earth. So thus, the Aristotelian uniqueness of the earth was completely changed into the plurality of the universe, and hence we again started asking the question, is anybody out there or are we alone? Now at that situation at that time, because of the lack of technology and other things, our concept, our search, our imagination, all those things was confined to the moon and to the Mars, the nearest object. It took a few more 100 years before the human being becomes cosmic communicating civilization. In 1886, Heinrich Hertz, he discovered the radio wave, and then few years after that, in 1894, Sir Jesse Bose invented the radio transmitter and receiver, and he demonstrated in Kolkata's town hall. Incidentally, today is for the Sir Jesse Bose's 166th birthday. And then a few months after Jesse Bose's demonstration of radio, Marconi also invented the radio transmitter and receiver. In that way, the radio was established, but the radio was used to communicate between one part of a seat to another part of seat, or from one city to another city. Now, with the more development, with the technological advancement, the people started communicating. They tried to communicate transatlantic way, that from Europe to USA. But while doing this transatlantic transmission of radio waves, they have found that there is a noise, there is a east-east noise is coming in from some particular area. So AT&T Bell Laboratory in 1933 appointed a young engineer called Karl Jansky to find out the source of this noise that is that is making this radio signal from Europe to America difficult to understand. Now, Karl Jansky made this type of antenna and he focused in the sky. And then he discovered that this noise is coming from a particular direction of our galaxy, of our sky. So that guy was a very clever guy. He immediately consulted the astronomer. And the astronomer told that the direction where you are telling that the noise is coming, that is actually the center of our galaxy. And thus, by accident, Karl Jansky invented the radio telescope, and that was the first time radio telescope was used to detect, to discover that the universe is actually very much radio loud. Then, after that, in 1960, Project Ozma, a modified version of this Karl Jansky's telescope, was used, Green Bank radio telescope by Professor Frank Drake of Cornell University, and this was the first effort of the human being to search for intelligent life. So this was called Project Ozma. Unfortunately, Professor Frank Drake has just passed away a few months ago. Then, 1977, the Ohio State University, they introduced a big telescope, which was actually conceptualized, and that was initiated in 1957, but it was functional in 1977 at Ohio State University, and that was named as Search for Extraterrestrial Intelligence. Thus, the name SETI appeared there. So this SETI at 77, it continued for a few years. But then, because of the lack of fund, it didn't continue. In 1995, again Project Phoenix and SETI Institute of Mountain View in California started by astronomer Jill Tarter and other people. But then, because of the money, 1995 and in 2004, this project was over. So at that time, partially NASA was funding this type of project, but then because there was no production, there was no signal, because it considered as a non-productive, so NASA stopped funding. And then in 2007, the Paul Allen, the co-founder of Microsoft Corporation, funded this search. So this is called Allen Telescope Array, ATA. So that suggested the project Phoenix. Finally, in 2015, the Breakthrough Initiative funded by the Yuri Milner and his wife, they started giving $100 million to observe from all the biggest telescopes and all the largest radio telescope in the world. So, from 1960 to 2014, these 6 long decades, we have searched for signal, for signature or artificial signals from alien, but we could not find out so far any signal, any signature that can imply that this is artificial signal originated from alien. So then the question arises, does they exist? Is alien exist? Or if they exist, then what should be their number in our galaxy? If we know, if we can make a rough estimation of their number, then we can tell that what will be the frequency at which we can receive their signal. Okay, so this type of number first proposed by Professor Frank Drake, who started this project Ozma in 1961. So he gave a empirical equation that the number of cosmic communicating civilization in our galaxy is a function of some number. So what are that? The first number, R star, is the mean rate of star formation in our galaxy. That is, in our galaxy, how many stars per year are born. Now you know this number. So for example, you see that if somebody asks you in your school that count the number of students in your school. So now what you have to do that you have to go to each class, count 1, 2, 3, 4, and then go to the next class, next section, all this section, class after that. But instead of that, if you know, if somebody tell you the average number of students in one section, and in how many sections are there in one class, how many classes are there, so from there you can find out a good approximation of the total number of students in that school. So without going from class to class or counting. So such type of thing is the Drake equation, that sitting on Earth you can scientifically or you can logically calculate some of the numbers, some of the parameters which can give you the number of cosmic communicating civilization like us, who can generate, who can receive artificial electromagnetic wave. Okay, so what is this R star value, the mean rate of the rate of star formation in our galaxy? That we now know at present. So in our galaxy, about half to 1.5 times of the solar material, of the solar mass of interstellar gas and dust is used, or they are converted into star each year. Now we know that the initial mass function, that is average mass of new stars, are half the mass of the sun. This could be less than solar mass, this could be higher than solar mass, but the average mass of the newly born star is half of the solar mass. So dividing these two quantity, we get the present mean rate of star formation in our galaxy from 1.36 to 2.9 years star per year. But this is the present value. But the number of stars in our galaxy is about 10 billion stars. So 200 billion of stars we can see. So at this rate it cannot produce so many stars. So definitely in the earlier stage the rate of star formation was much higher. So since the rate of star formation was much higher in the past, our galaxy, which is almost 10 billion years old, has about 10 to the power 11 stars. Therefore, the mean rate of star formation, that is taking the average over all the time, over all the 10 billion years, may be averaged to out to 10 to 20. So now we know that the first term, n is equal to 10. The other term has to be defined to find out that how many cosmic communicating or how many intelligent civilizations exist in our galaxy only. Okay. So the second question is FP, the fraction, the second parameter is the fraction of stars that host planets. Now although Giordano Bruno, although Sir Isaac Newton, they predicted that many of the stars which are similar to Sun should have planets, but nobody started searching because at that time there was no bigger telescope, or there was no photographic plate or anything so that they can search a planet outside the solar system. The first scientific and systematic search was reported by Captain William Jacob in Madras Observatory during 1855. So Madras Observatory was established in the present Chennai in 1786 by the British East India Company for the purpose of climate observation or prediction of the meteorological purposes, because the European ship was coming to the shore of Chennai, and you know that Vasco da Gama came from that side, so they needed the climate, the prediction of the climate. So they made an observatory called Madras Observatory in 1786. But then some of these directors, they used this observatory for astronomical observation because they are motivated in the stars and planets. So Captain William Stephen Jacob was the director during 1855, 1848 to 1859, and he monitored a star for a long time which is called 70 Ophiuchi, which was a binary star. So he, a few years he monitored the position of the binary stars, and he found that these two stars are not following Kepler's law. So there was an anomaly in their motion. So Captain Jacob suggested that if there is a planet, Jupiter size of planet in this double system, so if there is really a triple system, then that can explain the anomaly of the binary system of 70 Ophiuchi. Then successively many other scientists in USA, in Chicago University and even in Europe, they also found the same thing, and they supported this suggestion by Captain Jacob, who was actually in the British Army. And but then later on, when bigger telescope came, we got much better technology. Then we found that actually his calculation was not correct. He didn't take properly the atmospheric effect. But NASA considered this report as the first false alarm for exoplanets. So that's the Indian connection of the exoplanets. But then after that, this research, this report motivated several astronomers to search for planet outside the solar system, known as exoplanet or extrasolar planet. But for 150 years, all these attempts was in vain. People thought some faint stars as planets. Sometimes they thought some other false signal as planet. Finally, in 1995, a Swiss scientist, Michel Mayor, and his student Didier Queloz, they discovered for the first time a planet outside the solar system, orbiting around a sun type of star, 51 Pegasi b. So this picture is taken in 2013, long before he got the Nobel Prize. So for this discovery, Michel Mayor and Didier Queloz was awarded the Nobel Prize in Physics in 2019. Now, this discovery, you can see that this 51 Pegasi b, you can see this is the star. If you see in the sky, this is the star, and you cannot see the planet, because the planets are, even if they are reflected, they are very bright, they are hidden in the intense brightness of their star. They are so close to their star that you cannot resolve them, and you cannot distinguish them from their star. So astronomers take an indirect method to detect all these extrasolar planets. So Michel Mayor and Didier Queloz, they made a sophisticated instrument, and they used something called Doppler method or radial velocity method. So that's a detailed thing. I'm not going to explain you that method. But then just after 5 years, another method got very much popular, which is known as transit method. So the transit method was suggested by Otto Struve in 1952. So what happened, Doppler shift or the radial velocity method, which was used by Michel Mayor, needs a very sophisticated instrument. But transit method doesn't need any instrument, it is just a photometry. But the real challenge is in its data analysis, the noise. You have to reduce the noise from that. So since it doesn't need any much expenditure or any expensive instrument, so it becomes very popular. So what is this transit method? Now you know that every 140 years Venus transit the Sun. So last Venus transit was happened in June 6 in 2012. So when Venus transit across the Sun, you can see then the shadow of Venus as a small spot. But that reduces the brightness of the Sun, although very little. But this very good instrument can detect this fall in its brightness here, and it is periodic when it goes again. But this happens in a very longer period because of our position. So this same principle is used for the transit method. So when a planet very near to the stars or is a very big size, it transits across a star, the star's brightness reduces. Now from this reduction from this decrease in the brightness and its periodic behavior, that it reduces, then again become normal, then again reduces, astronomers detect the presence of a planet around the star. Now in 2000, for the first time, transit of an exoplanet HD 209458b was detected, and if the star has multiple planets, then you can see the modulation in their light curve. This is called the light curve, that is the brightness of the star that changes, that gets modulated. So suppose there are more than one planet or 3 planets, the light curve will reduce here much higher for the bigger planet, then there will be little bit for the smaller planet, and then if they simultaneously transit, then there will be a modulation. So in this way the multiple planet or the planetary systems are also discovered. And also if we use different wavelength or filter or different color, then we can find out if a planet has atmosphere or not, and how is the atmosphere. So once this transit method was used, before that, we had the solar system when only 8 planets we know. Earlier, for a century, 1930 Pluto was discovered, but in 2006, the International Astronomical Union, the Senate or the Parliament of the astronomer, it decided that the Pluto is not a planet, and that is because before that we didn't know how was Pluto. So then in 70s we discovered that Pluto has a sister called Charon, which is very massive. Means then the Pluto's whether Pluto is orbiting Charon or Charon is orbiting Pluto is a confusing thing, because the center of rotation is outside Pluto and outside Charon. So they act as a double planet. But so the Pluto is very small. Pluto is smaller than even Moon. But now with the discovery of this big giant planet, there was question arose. Every time in history, the number of planets got changes. So in 2006, the number of planets was reduced to 8. But we knew before 2005, we knew only these 8 planets. And we thought that our knowledge on planets is complete after Voyager, Viking, Pioneer, all those spacecraft passes through Jupiter, Saturn and all those planets. But then what happened, once at that time, the start 1995, when we discovered the first exoplanet, all the astronomers, most of the astronomers in the whole world, by using whatever telescope they have, started searching, hunting for planets. And every day, every month, every year, the number of planets outside the solar system was getting increased. So at that time, the search range was, because all those telescope was ground-based telescope, and the search was confined within 300 light years from the sun. Then NASA and ESO, the space agencies of the United States and the European Union came into the picture. And NASA sends a space telescope dedicated to find out the other world, the worlds beyond our own world, so the extrasolar planet. And in 2009, March 7, NASA launched the Kepler Space Telescope. Almost at the same time, the European Space Agency launched Korot, another space telescope dedicated to search for extraterrestrial planets. And as soon as Kepler and Korot becomes functional, we found a huge zoo of planets very near to us among all the stars, because our search area now increased because of the space telescope 10 times, so 3,000 light years. And then we found out such a diverse range of planets that it was beyond our imagination. We know that Jupiter is the largest planet in the solar system and it is very cool. We found some of the planets which are 1.5 times larger than Jupiter. Some of these Jupiter type of gas giants are so close to their star that they are so hot that even iron could also melt and gold could also melt. Some of them are some of them are slightly bigger than Earth but smaller than Neptune, so they are called mini Neptune. There are something called super Earth which are larger than Earth but smaller than Neptune. So all those type of planet was not known even in our solar system. At the same time, we also use the transit photometry method by using our Indian telescope in Indian Institute of Astrophysics. So we have used so far 2 telescopes. One is the Jagadish Chandra Bhattacharya telescope at Bhainuvappu Observatory, Kavalur in Tamil Nadu. That is a 1.5 meter. The diameter of the mirror of this telescope is 1.5 meter. And we have another telescope in Himalayan Chandra telescope at Indian Astronomical Observatory, Handle. This is in Ladakh, in Leh region, which is operated remotely in Hoskote. So using this telescope, we also monitor the stars and we find out the signal of the planet when it transits. So these red lines are the signal of the planet when it is transiting across the stellar disk. And then from this data, we model it, we reduce the noise and we analyze everything and we find out the precise value of the size of the planet, their mass, their period, everything. And from the mass and the radius, we can find out their surface gravity, their mean density. From the mean density, we can find out whether they are a gas planet or they are rocky planet. We can find out the temperature from their distance, if we know that the temperature of the sun. So all the full properties we find out So we have studied so many planets because in our India, the facilities, we have very limited number of telescopes. So we cannot go to discover new planets because that's a hectic time consuming thing. So what we decided that is not needed actually. Whatever planet we have discovered, we need to find out their parameters, their physical properties very precisely so that we can analyze their atmosphere much better way. So this is the blue one is from Himalayan Chandra telescope. The red one is from Jagadish Chandra Bose telescope. So Jagadish Chandra Bhattacharya telescope. Now you see, since this telescope is much bigger, it is a 2 meter class telescope, we get more data in the same time. So nevertheless, this was our research. But then some of the planets are directly imaged. So because they are quite young and they are so bright and they are far away from their star, that you can block the starlight by an instrument called coronagraph, and you can take even the image of this exoplanet. Most of these planets that is discovered, they are very near to the star, so they have to be discovered through the indirect method like radial velocity method or transit method. But some of the young planets which are far away from the star are discovered by just taking their photograph, their imaging. So this was the first image of a planet. This is in infrared light. And this is a peculiar object. This object is called the brown dwarf, which is the missing link between the stars and the planet. So earlier we knew that there is a huge difference in the mass of the star and the planet. So we know that the heaviest planet is Jupiter, and the lightest star is about 80 times Jupiter mass. But so what happened to in between this range? Now one Indian American scientist, he predicted that in 60s, his name is Kumar, so that there could be some object which will not ignite a nuclear burning inside a star. We tell a star when its core ignites deuterium or nuclear fusion initiate, and then it ignites helium, and then it starts burning continuously. But these objects are not much heavy, so they are not much hot, but they are born like a star, but they are missed to become a star. So this object is a missed star. It born as a star, but it could not become a star. These are called brown dwarf. And this fellow, we do not know how it is born. There is no way to know it, but it has missed to become a brown dwarf. So there was no nuclear burning happened. Here this object started nuclear burning, but failed to sustain the nuclear burning. This guy has not done it. So later on, there are system of planet has been imaged. So here you can see there are 3 planets initially discovered around a star called HR 8799. Then later on, the 5th planet was also discovered here. This 5th, A, B, C, D. So these are the planets which are imaged. Later on, even a planet and under formation, that is a protoplanetary disk, was also discovered around Beta Pictoris b. Then this one. So now all these are orbiting around a star. Then we discover some planets which are low planet or free floating. They don't have any parents also. So this is one planet. That has no star, nothing. This is orbiting the galactic center. So now it is thought that there are billions of such type of objects which are either born like a star or like a brown dwarf, or they were a member of a planetary system for other stars, and due to some reason they got torn up, they got kicked out from the planetary system, and they are floating freely. So this was the situation that our entire concept on planet and planetary system was completely revolutionized. Now, so how many planets we discovered? So by using all the methods, the astrometry method through which Captain Jacob predicted a planet, the radial velocity method through which Michel Mayor confirmed the first exoplanet, then the transit photometry method which Kepler, Corot and James Webb Space Telescope recently and we also use. Then there are gravitational microlensing, there are imaging, there are timings, all type of method we use, and then so far till date, just before coming here I checked the NASA's website, 5,539 planets has been discovered so far. So this is the confirmed exoplanet in 4,261 planetary systems. So by using some statistical method, we can find out the fraction of stars that host planet, that is Fp in the Drake equation, should lie from 0.5 to 1. That means it is a rule of the universe that every star should have average at least one planet. So if there is no planet, that is the exception, and other things are a rule. So Fp we now know. So let us go back to Drake equation. So we know the Fp, the fraction of star that host planet. The next parameter Ne is called the average number of rocky planets in the habitable zone per star that hosts planets. Now what is this habitable zone? Okay. So circumstellar habitable zone or Goldilocks zone is defined by a region around a star at such a distance that the thermal condition is appropriate for water to exist in liquid state. So the temperature of a planet is such that in that region that water can exist in liquid state. So that is called the habitable zone of the star. Now the habitable zone can be defined by this line, this blue line, and we can see that the Earth, these three planets are in the habitable zone, marginally Venus and Mars in Earth. So what happens? This is defined by the brightness or by the power emitted by the star. So if we consider the luminosity or the brightness of sun and we use this formula, and then we can find out the temperature from its distance, then we see that the temperature of Venus will become 55 degrees Celsius, Earth will become 5 degrees Celsius, and Mars is far away, it has an elliptical orbit, so it is minus 47 degrees Celsius. But we know that all planets and all objects have certain property, that is the reflectivity. So a certain amount of starlight or sunlight that it receives are reflected back to the space. So Earth reflects 30% of the sunlight it gets from the sun. So it's called the albedo. So Earth albedo is 0.3. So if you consider the albedo of this planet, then Venus has a very thick atmosphere and its albedo is 0.7. That means 70% of the sunlight that comes to Venus is being reflected. So the temperature of Venus will become minus 40 degree, Earth will become minus 15 degree, and Mars will become minus 60 degree. So none of the solar system planet will become habitable, and the habitable zone of the sun will become far away, will go far away from the sun. But we know that water exists in liquid state. In fact, water exists in all the three state, solid, liquid and gas on Earth. So how that has happened? So if somebody, some extraterrestrial intelligence try to search us, and if you only consider the stellar light, only the brightness of the sun, you will not find out, you will find out that all the three planets are habitable. But then you will consider the reflectivity, you will find out no planet is habitable. But then on the solar system, the Earth has only the ambient temperature that is appropriate for water to exist in liquid state. Now that's because of the greenhouse effect. So what is this greenhouse effect? Now when the sunlight in the optical, in the visible region falls, so it hits up the surface of the Earth. Now this surface again re-emits the radiation, and this radiation, re-emitted radiation is weaker in its energy. So it has a longer wavelength. The weaker is the energy, the longer is the wavelength. So when this wavelength, the weaker wavelength tries to go back to the space, it gets scattered by the molecules of the atmosphere. So there are carbon dioxide, there are oxygen, there are methane, there are several oxygen, and it gets scattered so many times with the Earth, with the atmosphere of the Earth, that it cannot escape the Earth atmosphere. It gets trapped into the Earth atmosphere and it warms up the Earth atmosphere. And that's what the greenhouse effect. So because of the greenhouse effect, the Earth's temperature increases by 33 degrees Celsius and makes it warmer. On Venus, what happened? There was a runaway greenhouse effect because it has a very thick atmosphere, mostly carbon dioxide. So temperature becomes 460 degrees Celsius. So that's why Venus is the hottest planet in the solar system, although Mercury is the nearest planet in the solar system. So the atmosphere plays a very important role in determining the ambient temperature, whether it could be habitable or it cannot be habitable there. So now we have to search for rocky planets in this habitable zone. So in a region where water can exist in liquid state, but if it is a gas planet, water, even if water can exist in liquid state, it cannot be retained. So a solid surface is needed. So therefore we have to search for rocky planets in the habitable zone. So that is the scientific search. So now the analysis of data obtained by NASA's Kepler Space Telescope indicates that 2 to 12% of stars, mostly the smallest and the faintest one, that is called the M dwarf star or the red dwarf star in our galaxy, have rocky planets in their habitable zone. And also then all method, we make the statistics that about half of sunlight stars should have a rocky planet in their habitable zone. And there are quite a few potentially habitable exoplanets, that is rocky planet in the habitable zone of the star has been discovered. And that recently we also told that even a rocky moon in the habitable zone, even if the star, even the planet is gaseous, but if its moon is rocky and it has the ambient environment like which can keep water in liquid state, may also hold life. You know that Titan has an atmosphere. Titan is Saturn's moon, largest moon, that is the second largest moon in the solar system. Enceladus has water ocean, but their temperature is so low that they cannot harbor life on them. But some of these moon, if they were in the situation of Earth, if Earth moon had an atmosphere, there could have been every possibility life could have existed. So we have to consider this moon also. So recently we found that how to detect. So far no exomoon, that is moon around exoplanet, is discovered. Recently we have shown that even James Webb Space Telescope may be marginally detect such type of exomoon in the habitable zone. So the average number, the average number of rocky planets in the habitable zone for star that hosts planets would be N is equal to 1 to 3. So if a planet, if a star hosts planets, then it may have 1 to 3 by average rocky planet in their habitable zone. So get back to that. So average number of rocky planets in the habitable zone per star that hosts planets is that number. So the next parameter is fraction of rocky planets in the habitable zone that we have discussed just now, that actually harbor life. Now that leads to us to a more fundamental question: what is life? Now our knowledge on life is based on the millions of species, millions of organisms that we see on the earth. And that varies from one unicellular amoeba, bacteria, to even the blue whale. So such type of varieties are there. Now when I search for the definition of life, I stop after counting, after I think up to 98 I counted and I stopped there. And then that doesn't add the philosophical definition of the planet, that will increase again. So there is no universal definition of life. So no universal definition of life. Now if 400 years ago you were asked that what is water, you could have taken the description only. So you could have told, oh, water is a liquid, colorless, odorless, it flows from top to bottom. But then somebody will come with a beaker of ethyl alcohol and tell that, look, this is also liquid, this is also colorless, odorless, so how you will distinguish? But today if somebody asks you that water is a molecule consisting of 2 atoms of hydrogen and 1 atom of oxygen, and even if you can express it as a mathematical formula like H2O, then by using your knowledge on atomic energy, a little bit of quantum mechanics or electrons property, you can derive all the physical and chemical properties of water that can distinguish this molecule from all other molecules. But such type of precise definition doesn't exist for life, because life is a function, life is a system of functions. So we can define some of the important functions of life that distinguishes life from non-life, from non-living organisms. So what we basically tell that life is an ensemble of organic material governed by self-sustaining, synchronized system of chemical process and characterized by metabolism, replication and evolution through natural selection. So that is the Darwinian theory. Now what is this organic material? So organic material are basically compounds made of carbon, hydrogen and oxygen. Now where this organic material is synthesized or where it has come from? About 90 years ago, two scientists, Oparin and Halden, they suggested that the organic material and art was synthesized out of the inorganic material on the art itself under some primitive condition that prevailed during that early situation, that is 4 billion years ago. Now about 70 years ago, two scientists, Urey and Miller, they performed a laboratory experiment where they produced amino acid, the building block of life, that is the organic thing, out of some inorganic material by passing a lightning or spark, electric spark into that mixture and produces this amino acid, and then they got the Nobel Prize because of their discovery. And after this Urey-Miller experiment and discovery, people started believing that then definitely if organic material was formed out of inorganic material on the art itself, then life might have also formed out of the inorganic material or out from the chemical evolution, it entered into the biochemical evolution. But now we see that organic materials are being imported by meteorite. And even water and organic material is found in this type of material. This was found in Australia. And then with the improvement of infrared chemistry, we found that the interstellar medium is actually a big factory of organic material. All type of organic materials are being produced in the interstellar medium, and a kind of star which is at the late stage of a sun-like star called asymptotic giant white star, which has an envelope that has the appropriate condition to produce a huge amount of organic material here. So this even the silicon is what we are seeing on Earth are produced in this asymptotic giant white star. So with that, the question even arises that then really organic material was synthesized on the Earth itself out of the inorganic material, or it has been imported from the interstellar material. Now incidentally, the Urey-Miller experiment or all the other improved experiment that found only one amino acid out of all the 20 amino acids that can build the protein. Here also the situation is there that we found the amino acid, but very few of them are used in our body. So the controversy remains whether the organic material itself has been is synthesized on the Earth, or it has been imported from the outer space, and so whether life is synthesized here on the Earth, or it was being imported to the Earth from the interstellar medium. We do not know. The metabolism is the procedure in a living cell that store, that receive, that store, and that produces energy. So metabolism is stopped, we call the body is dead. So this is very important thing, and this energy exchange happens in a cell called in a body in the cell that is called mitochondria. Then the replication through which a cell makes its own exact same copy, and it transfers the information from one generation to another generation, and this is the Darwinism where the evolution things we consider it. Now the thing is that this evolution is very important. Now what is this evolution? So suppose this is a mistake of the gene. Suppose there is a book, only one book is there in a whole class, and you have no Xerox machine, no photocopier, nothing is there, but everybody wants one copy of that book. So the first person, he or she copies from that original book and then passes his or her copy to the next person. Now while copying, he may intentionally or unintentionally a few mistakes, say 5 mistakes. Then passes the book's his copy or her copy to the next person. The next person didn't know about this mistake, so he or she writes the whole book, copied the whole book, but then he also introduced a few mistakes. Then passes his copy to the next person. The next person also did it there. So ultimately when the book will go to the last person, you can see, and if you compare the original book, you will see that the entire book has been changed. Now if the new book has some meaning, it will survive, or otherwise nobody will read, it will be completely extinct. So that is the way the evolution takes place. So if we find out one cat, one dog on Mars, we can tell very certainly that there may be many cats, many dogs, and many of their progenitors on the Mars. If we don't find them, then we can confidently tell that they are imported from somewhere else and they were not born in Mars. So evolution or the Darwinism plays an important role. But you know, the description is always incomplete. One can question that an embryo is not self-sustaining, but it is a life. So how do you tell it? But for an astronomer, finding out the mother is sufficient. We need not go for the embryo. So like that, so NASA has given a very working definition of life, that life is a self-sustaining chemical system capable of Darwinian evolution. Now in the same way, we can define the intelligent life, that intelligent life is a living species that are capable of receiving, generating and transmitting artificial electromagnetic wave. So the situation is that we do not know the origin of life on Earth. So most of the people believe that on Earth life has originated from chemical evolution to the biochemical evolution. Initially the RNA, the ribonucleic acid, that can store information, that evolved into ribosome, which can both store the information and can catalyze or make protein. So from ribosome, the DNA was formed, deoxyribonucleic acid, and thus from chemical evolution, it entered to somehow, we don't know how, into the biochemical evolution. But whatever be the origin of life, whatever be the origin of organic life, we know one thing, that it needs several rare combination of astronomical and geological conditions that supports life or that enable life to survive on a planet or on a place and to enable it to evolve. Now what are those conditions? There are many conditions. I will just tell a few things. The giant planets are protectors of the Earth. So the solar system configuration itself is supporting life on Earth. So in our solar system, we know that the outer region, the planets are in the rocky planets are in the inner region, the gas planets are outside, and at the end there is a belt type of structure, which is the leftover after the planet was formed. These are called Kuiper belt objects. The short period comets are born here, and then outside there is a cloud, wood cloud. This is the leftover after the sun itself was born. So long period comets are born here, and all these comets are rushing towards sun in a highly elliptical orbit, so it could frequently collide with Earth. But then what happened? The gravitational force that is by Jupiter, by Saturn, by Uranus, that deviates this the position of this comets, and therefore the rate of collision of comets with the Earth reduces enormously. So most of these gas planets, these giant planets, that takes the hit by this comet, or they deviate the orbit of this comet, so that there is no collision. The frequency of the collision is very rare. So therefore, if those planetary systems where the giant planets are much nearer and the rocky planets or the habitable planets are far away, they will suffer huge collisions by asteroid and by the comet, and their life cannot survive. So similarly, next is the magnetic field. So we know that the sun is very active. Sometimes suns become so active that it emits a flare, giant flare, copious amount of energetic charged particle emits from the sun. It comes to the Earth. If it would have entered into Earth's atmosphere, it would have destroyed the Earth's atmosphere. But Earth's geomagnetic field, it doesn't allow this charged particle to enter into the atmosphere. It can enter only through the open pole, that is in the North Pole and South Pole, giving rise to the spectacular aurora borealis. So if this geomagnetic field was not there, then this charged particle, that is energetic charged particle, comes through the flare of the sun, could have destroyed the atmosphere and the biosphere of the Earth. Now another thing is there. We know that our season, the autumn, the winter, the summer, that happens not because of the Earth's orbit around the sun. it happens because of the tilted, the orbit of the rotation of the orbit of the Earth is tilted by 23.4 degrees. And this has caused a precession at about 19,000 to 24,000 years. So now you see the pole star all the time constant. So after 15,000 years, you will see Virgo star, Vega star all the time in that. So because of this precession. Now this tilt angle is also not constant. So every 41,000 years, this tilt angle changes from 21.5 degree to 24.5 degree, and so now it is 23.4 degree. And also the ellipticity and the plane of things also changes. So this is a very minor dynamical change that makes the atmosphere or the climate of the Earth very stable. And you know who is responsible for causing this stable dynamical effect or this stable atmosphere? That is our beloved moon. So moon was born 50 million years after the birth of the Earth. So when the Earth was just a nascent, just a kid, just an infant stage, a massive object named Theia. The Theia was of the size of Mars, which collided with Earth. So huge. At that time, before the collision, the Earth was rotating so fast that instead of 24 hours, the one day was 8 hours to 10 hours. And its orbit was completely perpendicular to the plane. But then the Theia collapsed. It collided in such a way the Earth could have been completely destroyed. So, but because of the mass of the Earth, it is sufficiently massive that the Earth didn't destroy. The debris that came out, that again coagulated and given birth to the moon. And now it is because of the moon's gravitational effect, we saw the tide that causes the atmospheric effect. So not only that, this moon plays a tag of war with the giant planet like Jupiter and Saturn. Otherwise, Jupiter and Saturn's gravitational pull would have made this orbital tilt much chaotic, causing much chaotic climate, which could have made the Earth's atmosphere much more inhabitable. So, for example, Mars, it doesn't have a massive moon, it has only two small Deimos and Phobos. So, it has a very chaotic change in its tilt axis, and therefore its climate is very chaotic and uninhabitable. So that is one reason that a massive moon is needed, which is protecting life from the Earth. But the problem is that we cannot know from here whether a planet has such type of all these criteria for life to survive. So what we will do, how we will find out life on other planets? So now if you send so we will go for biosignature. Now what is this biosignature? So if you put the light from any planet or Mars or Venus through an instrument called spectrograph and take the spectrum of the star, you can get a spectrum which will give you some absorption line, some dark line in the spectrum, and that is associated with various elements present in the atmosphere of this planet. So if you take Earth, Venus and Mars spectrum, you will find out that the signature of carbon dioxide in all the three planets, but in addition to carbon dioxide, Earth will have plenty of water signal, and there will be oxygen and ozone. Now this oxygen, the oxygen molecule was not there on Earth at the early stage. All the oxygen atoms that was available on the Earth were combined with carbon, with hydrogen to form molecules like carbon dioxide, silicon oxide, water, etc. So only 3.9 million years ago, a bacteria called cyanobacteria started photosynthesis, which has given rise to a large amount of oxygen molecule. Now this oxygen molecule, when it goes to the top of the atmosphere, it gets heated up by the ultraviolet radiation of the sun, and it becomes oxygen atom. Now one oxygen molecule and one oxygen atom combines to make an ozone molecule. So that ozone molecule is protecting us from the energetic ultraviolet ray of the sun. So this ozone and the water, oxygen serve as a biosignature for us because they are produced biologically. Similarly, in an oxygenic atmosphere, if methane is found, that could be a biosignature because methane, in an oxygenic atmosphere, methane reacts with oxygen to become carbon dioxide and water. But if the equilibrium is violated, if we see excess methane, then we can tell that there are biochemical processes going on. So, for example, that's why we are searching the signature of methane on the Mars subsurface to know that if there is methane, if there is life, or once upon a time if there was life or not. But for extrasolar planets, such type of direct spectrum is not possible. So the astronomers, they take another method that is called the transmission spectra of the exoplanet. So what they do that, they first pass the starlight through the spectrograph and take the spectrum of the star. Then what happens, this is taken when the planet is not transmitting, not blocking the star. But then they take another spectrum when the planet is transiting them, and so the light from the star that passes through the atmosphere of the planet. So now this spectrum, the first spectrum has only the signature of the star, but the second spectrum has the combination of the star and the planetary atmosphere. So by subtracting the first spectrum from the second spectrum, we can find out the signature of the molecule that is present in the planet. So this transmission spectra we can model for Earth-like planet, Earth-like exoplanet, and this is we have done in 2020. This year it is published by one of my students, Monika Singla and Aditya Chakravarti, and we can show that if you numerically simulate, you can find out the oxygen molecule, ozone molecule, carbon dioxide, etc. But such type of accurate spectrum right now is not possible to obtain because of our lack in technology. Our telescope or our instrument capacity can take, of course, the transmission spectra of gas giant planets which are very near, but probably James Webb Space Telescope may marginally can find out the spectrum of rocky planet in the habitable zone of some faint star that is called M-dwarf star, and we will find out if biosignature is available there or not. So in future James Webb Space Telescope may marginally detect, but within this decade we are going to have 3 large telescopes. One is European extra large telescope, which will have 42 meters in its diameter. There will be 30-meter telescopes with which we the Indians are collaborating, which will have a mirror of 30 meters. James Webb Space Telescope has a mirror of 6 meters, and Hubble Space Telescope has a mirror of 2 meters. So our technology is improving, and with this we hope that one day we can detect the biosignature from this from any of these planets, and so we can go back to the Drake equation. And right now the status is that we have no idea about the fraction of rocky planets in the habitable zone that actually harbor life. But I think very soon, within a decade, we will find out biosignature, and then we can tell it. Now subsequently the other parameter, API, the fraction of life hosting planets that harbor intelligent life, that is also uncertain. Now what happens that if a planet has life, it doesn't make automatically that it will evolve into intelligent life, because evolution is a probabilistic method, it is not deterministic. So suppose that if dinosaur was not extinct, then this evolution into hominid and other things may not have possible, or intelligent life may have also extinct because of all this herbivores or all those big giant predators. So we do not know even that whether it is certain that any planet which has life can also evolve into intelligent life. And of course, if intelligent life comes into being, then they may be, because of their curiosity or their like us, we were curious about it, they may one day become alien civilization or intelligent alien civilization that can communicate. So we have no idea about all these 3 parameters. Now, depending on what we know, we can estimate the 2 situations. One is mediocrity, that is proposed by Carl Sagan and Frank Drake, just to get fund from the government agency or other agency. They say that there could be many intelligent life. So in the Drake equation, the number of cosmic communicating intelligent life is expressed by this parameter. Here, this green one, we know these 3 parameters reasonably well, and but we do not know FL, FI and FC. There is no way. This L is the average length of time those civilizations can communicate, that is how long they will survive. For Earth, we have survived more than 140 years, as I was telling that the discovery of radio wave and the radio was discovered 140 years ago. And if we consider this, the product of FL, I and FC, this will be certainly greater than 0 because we exist. But this will be less than 1 and we do not know how small this is. So if we parameterize, if we calculate, if we estimate by seeing that, by taking the Earth star is 10, that is 10 stars per year is produced in our galaxy, then we find out that the number of this P, if we take 1000 years, and if this P is very less 10 to the power minus 4, then we will be the only civilization. So that is the rarity. On the other hand, if they survive for 10 to the power 6 years and the P is 1, that means even if there is a P is equal to 1 means if there is a planet in the habitable zone, that will definitely origin life, and that life will definitely evolve into intelligent life, and that intelligent life will definitely go into cosmic communicating life. Then there will be 10 billion lives within every 15 light year distance, and the below one is the light year at which distance they will be distributed. So now we do not know whether we are the only civilization in our galaxy, or there are several intelligent life, or there are only nascent life, or what is the situation. But we hope that in future, once we get the biosignature, then our statistics, our number will become more stringent. Now I come to this L. So you can see that depending on the L, the number of cosmic communicating civilization increases a lot. So what is this L? Now the space, although it is a very vast, it is a very dangerous space. So there are potential danger, astronomical danger. The collision by a comet or a giant asteroid may destroy life on our planet. So although Jupiter and Saturn are protecting us, but some comet may just miss the clutch of Jupiter's and Saturn's gravitation and can hit, like that I told that 60 million years ago. A comet probably hit the Earth's atmosphere. The Earth's atmosphere got completely covered by dust, sunlight could not enter, and almost all the developed species, including dinosaurs, was extinct at that time. There could be a supernova explosion, that is, if a massive star at the end of its life, it explodes into supernova and it emits copious amount of energy, the alpha ray, gamma ray energy, X-ray energy. So if within 30 light years of Earth, a supernova, a star explodes into supernova, our biosphere will be completely destroyed and it will be irrecoverable damage to the atmosphere. There is a gamma ray burst. So gamma ray bursts are the most energetic source in our universe. When two neutron stars, that is the end product of two massive objects which exceed, which are about or exceed the Chandrasekhar limit, they collide. They give rise to copious amount gamma ray. So if one gamma ray burst happens in our galaxy, the entire galaxy will lighten up. There will be entire Deepavali of the galaxy, and because of that gamma ray, intense gamma ray, our atmosphere will be completely damaged. And Sun is usually an ordinary star, so it's a very quiet, it's a very gentleman. But we do not know if in future the Sun emits a giant flare that can destroy the magnetic field of the geomagnetic field of the Earth, and thus it can hit the atmosphere, it can destroy the atmosphere. Yeah, just 2 minutes. The atmosphere for life. Now, in addition to that, there are terrestrial disasters like the super earthquake, we know super tsunami or volcanoes. In fact, the Earth suffered at least 6 extinctions in its life because of the earthquake, massive earthquake, the plate tectonics of that. But the imminent disasters, these are all rare. So these astronomical and terrestrial things, although their possibilities there, they are very rare, but the imminent things are the man-made disaster. So if a nuclear or chemical, accidental nuclear or chemical or biological where takes place, our atmosphere can get completely irreversibly damaged. Now the expansion of the civilization, the industry, that reduces the drinking water level, the sweet water level on the ground, it is increasing the temperature, and there is already global warming up, and there could be the silicon and carbon cycle that maintains the amount of carbon in the atmosphere will be destroyed, and there will be ozone hole. Already we have seen that if there is a more temperature, so the earth temperature will be very high. So now the question is, whatever be the possibility of the existence of alien, whatever be the possibility of their number, so the fact is that we have not received any signal, any signature from anywhere that can tell about the presence of any life or any intelligent life. Now no signal, no signature of any artificial activities even in the farthest corner of the galaxy says that we are actually very lonely, we are very alone. So believe it or not, we are very alone, very lonely in our galaxy. Accept it or not, if natural disaster hits us, nobody will be there to protect us, to save us, nowhere we can go go outside. So our planet, the planet Earth, is so unique, yet so common, yet so unique. It is so great, yet so vulnerable. It is so crowded, yet it is so lonely. We all are in a boat, a mote of dust suspended in the sunbeam and floating in the vast emptiness of the cosmos. And therefore, it is our responsibility to protect this planet. We should, irrespective of our caste, creed, and country, we should not allow our ego, our irresponsibility, our ignorance to destroy this planet, so that generation of young people, generation of children can keep on smiling on this planet.
Thank you, sir, for your wonderfully illustrated session and most importantly, telling us who we really are. If you have any queries for the speaker, we might take a little bit questions, and the questions might be taken from our remote audiences as well. So please let us know, our people are there with you. Do be ready with your microphone while we take the questions from here. Yes.
So I will tell that if you are interested to know in more detail, you read my book.
Could we just have a little bit of
Bengali, that is Grow Take a Grohantore. If you cannot read Bengali, then you better learn Bengali, or you go to the English version of the book, What's Beyond Our Own, the search for habitable planet. You will get all the answers, all the details of whatever I have talked to you.
Good afternoon, sir.
Good afternoon.
Sir, as you have already spoken about the extraterrestrial life and if it may or may not, be present, it's a quite probabilistic game. What I inferred from your lectures is that it's a really a game of luck that all of us have been able to survive the race against astronomy, against our galaxies, right? So, right now in the Earth as well, we have so many countries and there are inter-country dynamics, geopolitical dynamics. We cannot manage our own people. So if we happen to get some biosignature of any other extraterrestrial life or intelligence, or if we ever have a chance to meet them, though they are billions of light years away, so first we need to have that transportation facility, right sir? That is as fast as light or relatively as fast as light, right? So if that would take us billions of years, and by the time we reach them, how do you think that they will be welcoming us or we will be welcoming them? What would our conversations be like? This is first question. Second is, whatever the night sky that we are seeing or observing, the image that we are getting, that is also billions of years old, right? That is not the recent or current image, because that is coming to us, that signal is arriving to us after a lot of red light shift. So, by the time that we get a biosignature, how can we be sure that life still sustains in that planet? These are the two questions. Thank you, sir.
So your first question is that if we cannot travel to the planet, then what is the need of cycling, right? I hope that you have traveled in aeroplane or at least in train. Now the train didn't come before the bull cart, didn't come before the discovery of the wheel. So our technology is just 200 years old. So right now we can go up to Mars, we can reach to Chandrayaan. We do not know what will be happening in next 100 years. So when I was in your age, we used to go to STD booths to call my parents there and give a big queue. You people remember that after 9 o'clock night there was a half. And now we are carrying the mobile phone, the entire world in our with us. So the technology improved within 20 years. So we do not know how the technology will improve within another 100 years, another 1000 years. But if we do not start from right now, we cannot directly go to the speed of light or sub speed of light there. So first we discovered the wheel, then we discovered the bull car, then we discovered the motor car, then we discovered the helicopter, then aeroplane, then only all those come. So that is the progress. So with the progress of technology, and the thing is that it is not the benefit, the physical benefit, our knowledge. It will, if we discover biosignature, it will revolutionize our perception that our humbleness, our delusion that we are the only boss of this universe will be completely destroyed. We will not be there. And the Copernican theory for life will also be applicable, that life is not a special thing for only for the earth. It is everywhere in the universe. So that is the whole thing, that is the whole knowledge we want to know. We want to know whether the laws of biology are same everywhere in the whole universe. Right now we know that the laws of physics is same everywhere. If you throw an apple, it will fall on you. If you go to the remotest corner of the universe, and there also the Newton's law will be true, the Faraday rules and Maxwell equation all will be true. But we do not know whether the laws of biology are same everywhere because we have only one species right now. So if we discover some sort of like some biosignature somewhere, we can tell that whether the laws of biology are same or not. Now the thing is that if the laws of biology are different, we cannot recognize that as a life. Unless and until that is intelligent life and tell us that look, I am also alive, but my biology is different. Then we will find out the laws of biology are not same. So this is the knowledge, this is the enormous progress that we will make in our civilization. So that's what we are doing it. The second question that you asked, what is the second question? Can you remind me? Your was related to what?
It takes time. That's why.
So the second question is that if we get the biosignature of any other
yeah. So you are telling that how it will take. See, the thing is that we know that how you evolve. When Aristotle proposed all those things there was religious support for that, and that protected, and our civilization didn't progress for 2000 years. But now we have become much more, I think, broader. We have now started accepting the fact. So I do not know what will be the effect of our civilization, what will be thing, but we should welcome the new thing. As I am telling that our dogma, our humbleness, our delusion that we are the boss of the universe will be completely destroyed if we discover life. And another thing is that how that life will behave with us, that we do not know. But we know with the human being what we will do. We will colonize. As we did it, the Columbus discovery of America did it. We completely colonized it. We destroyed the Red Indian. So we should not do it. Now we are much more mature as a human being. And so as our technology and as our science develop, we also become more mature. We know how to protect. Now there is a rule that whichever country will land a space probe in whichever planet, it should not be near a place where there is possibility of water. So that if there is a possible life, it should not be destroyed. Very soon, I think this moon mission, Mars mission will be stopped by other countries. So whatever this Elon Musk or Mr. X tells it there, the human beings are becoming much more conscious about life. So that is the case. So now, whether alien exists or not, whether alien will communicate with us or not, or what they will do, that's a big speculation thing. I cannot speculate because science, there is no place of speculation in science. We take some certain hypotheses which are provable or which are disprovable. So we do experiment one by one. If we go systematically, like here in this case, we first find out how many planets, as many planets as possible. whichever be the kind. Then we find among those planets how many planets are rocky in the habitable zone. Then we will take those planets spectra. Then we will find out if they have atmosphere or not, because many planets like Mercury doesn't have any atmosphere. Then we will search for the biosignature. So this is one by one step we will go. This is the scientific research. For intelligent life also, it's much more difficult thing, because we do not know at which wavelength they will send the signal, what type of signal they will send. So, but biosignature is much more scientific or much more easier compared to getting the intelligent signal. So, intelligent signal is more speculative than the biosignature. So, that's why the biosignature is much more specific than the technosignature. Technosignature, we may not know that what will be the signal, but biosignature we know, because we are looking for Earth-based life, the signature produced by the Earth-based life. If there are other type of life, we cannot recognize them as life unless and until it is intelligent life and tell us that I am also alive.
Thank you, sir. Thank you, sir, for the wonderful presentation and the answers for sure. Sir, I have two simple questions. One you have already answered now a bit, but still I'll ask, like, how, are there any ways, a bit like as of now, for an estimation to categorize techno-signatures, means to some extent? And second is, like, what's your thought on India's part and its role, its place in future astrobiological missions?
Very good question. So the thing is that we are using the traditional thing as radio wave. So we know the radio wavelength is very long. It can vary from few centimeter to few kilometers. It can penetrate the atmosphere. It can penetrate many of the interstellar blockage or many things. So radio wave we are using it. And this radio wave, you know, it depends on the cost. The cost factor depends on the energy. So we expect that the intelligent life will send in a narrow band, and that will be periodic. So most of these natural signals are there on broadband, and they are not necessarily periodic. And this will be we send the signal in a multiple of pi, because pi is a transcendental mathematical thing. So then there is a hydrogen one line. So such type of strategy is taken. So that, but then intelligent life can send by high power laser beam also. So that also we saw. Recently I have proposed that neutrinos can be also used. This is advanced civilization. They need not bother for us, but they need to communicate among themselves. And they will send the message in one neutrino beam to another neutrino beam, which will be very expensive for us right now, but for those people it will not be that expensive thing. So there are various ways. Even there are OT, so this is SETI, search for extraterrestrial intelligence. There are OSETI, optical search for extraterrestrial intelligence. So there, whenever we get this habitable planet, rocky habitable planet, SETI also, the radio astronomer also focus on those type of planets to find out if there is any artificial signal is coming or not. So now SETI, I am one of the signatories, as Sangram has mentioned it. The aim is to find out individual stars. So we have already searched for 1 million star at least for signal and signature. But that is true. We do not know that which way the signal will come. But we only tell that what way we are sending the signal. We are coding it into our genes structure. We are coding it into our position. We are coding into our shape, size, and we assume that it's a binary type of code. So we give the number 1, 2, 3, 4. There are, you can Google search and you can find out that how these signals are made and sent there. But we do not know that what the intelligent life will send it. Those are completely speculative things.
Thank you, sir. Any questions from our remote audiences?
You can ask me in Bengali also if you want it. Yeah.
Hello. If you have any question, then please raise your hand.
There are people with the microphone there. If you have any questions in the demo hall, Loreto Elliott Road or South Point Institute.
Any question? Okay.
Yes, we have a hand up. Can we, people in that room.
For asking your question, you mention your name and your school.
Hello, sir. I'm Sogit Bera from South Point Institute. I have a question for you.
Yes, carry on.
Sir, if the aliens use the advanced technology we haven't developed yet, then what we will do?
Cannot do anything. We cannot do anything, but if we realize that they send it, then we will discover something new. We did not wait for it. Before we invent it, we will get it. In fact, some people speculate that the superconductor was sent by the interstellar intelligent life. So this type of conspiracy theories are there that we suddenly discovered superconductors that might have been sent by the alien life. So if they send something, we will miss it. That's all.
That's all, sir.
Any more questions from the demo hall again?
By the way, you are from
Any more question?
which school?
Anyone?
This is which school? This is South Point. I will tell. I had a very little class 6 fan of South Point school. Once upon a time, he asked me, who told me that, sir, once I grow up, I will become an astronomer like you. So I replied to him, and that I want to reply to all of you. Once you become an astronomer, you will not grow up. Thank you, South Point.
Question?
Okay, there is no more question. I think.
All right. So we have plenty of hands here. Yes.
You can ask me in Bengali if you want. There is no problem.
Greetings, sir. A lot of questions have been curated by me, myself, and my friends.
Yeah, ask one question so that everybody gets the chance, and question should not be longer than the answer.
Sir, one friend asks that, do you think that in 100 years, after that, the enthusiasm in discovering life, will it corrode or will it fade away in 100 years if we not be able to discover it in the future? In 100 years, or will it be the same as we are having it right now?
That is up to you people, how you will be motivated. That is the whole purpose of my giving the talk. You become astronomer and you will continue the search. But I will tell you that when I met the Yuri Milner and they came, the NASA director came to Bangalore. So we called all the IT people who are amateur astronomers who are very interested. So we have given them the setting software. We told them this is called the cloud software, cloud support. So those IT people, they in their spare time, they will build the software and they will analyze all the signals because we have terabyte of data. So in this way also all people from all professions start and support us. So after 100 years maybe we will be more enthusiastic because now you see we have 2 meter plus Hubble Space Telescope, then we send dedicated telescope, then we send 6 meter plus of telescope. We are building 30 meter, 40 meter plus telescope. So our enthusiasm with the development and technology is increasing up, not decreasing. Because the motivation of you people, the younger people is much more than what we had. Our time the exposure was very less. We didn't know about all type of things. We didn't have Google Baba. So now you have all type of things. So I think your interests are now increasing and you get the chance to interact with me. And for me, I have to write a letter by post to Dr. Santima Chattopadhyay for getting one answer in 2 months time. And now you can write me email, you can phone me, you can come to the meeting and you can ask the question. So the enthusiasm is increasing.
Sir, I had 2 more questions last. What are the latest advancements made in sending a satellite to the exoplanets?
Exoplanet we have not yet done. The last one, the Voyager 1 and Voyager 2 was sent in 1977. Possibly when your parents was not born at that time, I was in school. So that has just crossed the solar system. Because of that speed. Because that time the technology was not high. But now there are researches going on that if we can speed up the spacecraft, our nearest star is, Alpha Centauri system. So Alpha Centauri is Alpha Centauri A and Alpha Centauri B, 2 stars. And to that combination, another star, Proxima Centauri, is orbiting, which has a planet. Now this is 4 light years away. That means the nearest stars from which the light takes 4 years to come. So at the present technology, if we send a rocket, it will take 76,000 years to reach there. But we will increase, we do not know in 1,000 years what we will discover. So it's a Newton one, how many, 500 years ago Newton was there, before that we didn't know anything. You know now, dark matter, dark energy, Einstein was just less than 100 years ago. So you do not know that what will be happening in 1,000 years ago. We have to reborn.
Yeah, so the last question, what is the provenance of Area 51? Many people consider that.
That's bullshit, nothing is there. Area 57, that was a propaganda, that was a secret thing. Whatever you go, you get it there, that is... See, I will say that earlier we used to have that Nikon, Canon, all those cameras. with such type of resolution. Now the resolution is gone to very high, still we are seeing the UFO as a very faint object, nothing is there. So these are all mock pictures. Now most of the things, this Area 59 and all those propaganda, during the Cold War, when the United States and Soviet Union was quite enemy, they used to send quite a few spy satellites to the sky. So that I told you the Kavalur Observatory, where our geological telescope was there, that actually that place's name was Star. So that project was going on Star. So you will think that it is a star, so they are observing a star, but actual code name was satellite tracking and ranging. So the Soviet guys are tracking the American satellite from that center. And so if anybody comes and look, and they will tell that that is a UFO. This project BGR, once they detected some strong radio signal. Then they were searching because there was no repeat. Later on was found that one fighter jet B-16 was flying high altitude over the Soviet Union, and that radio signal came to the telescope. Then there was O signal by Project Ozma. So such type of signal comes which analyze, but we cannot analyze each and everything that people tell us, because we need solid evidences. As Carl Sagan told us, extraordinary claim needs extraordinary evidence, and that extraordinary evidence cannot be the testimony of eyewitness. So Area 59, I don't think there is any scientifically, any declared by government or anything or there. There is nothing for the alien, because if alien comes with them all those technology, they will not be visible only for one pilot or only for 1 or 2 persons. They will come, they will occupy, they will whatever they want to do, they will do. So suppose now with our intelligence and with our technology, we are unable to, how many? Only 12 human beings has landed on moon so far. We have done our first moon landing in the 60s. So imagine how much power, how much technology we should have to go to other planet. Now if they come to us, do you think that they will be stupid or they will be fool to be visible with 1 or 2%? That is not possible.
Good afternoon, sir. I am from St. James's School, and my question for you today is that does the absence of any expected biosignature rule out habitability, or can we expect other life forms or conditions to exist?
That's what I told you, that there may be, we do not know whether so far we have only one place, that is the Earth. So the only species we have on this planet, the life, and the life has a specific biochemistry, we know it. So now you see, if you lose one key and you search it everywhere, somebody asks you, hey, what are you searching? You will tell that, I don't know what I am searching. Everybody will laugh. So we have to first define that what we are searching for. So we are searching for life which are similar to Earth-based life. If it is not Earth-based life of thing, we cannot recognize it. That's what I told you, that we cannot recognize you. Habitable planet, okay, there are something called extremophile, that some form of life in bacteria form or unicellular form, there could be multicellular also. They can survive under extreme condition, means they can survive under 130 degrees Celsius, they can survive under heavy radiation, they can survive under very cold situation. I think Professor Samram was doing all those things there. So there could be there in some of the planets which are apparently uninhabitable to us, but they cannot evolve into a complex and intelligent life. So we suspect that Mars subsurface has such type of extremophile, and so we are searching for methane signature to see that if there are extremophiles in Mars surface. But if the life is so this is the problem, but what happened that this is a rare combination and coincidence of the geological and astronomical condition that makes the life Earth habitable. But then we have 200 billion of stars in our galaxy, 200 billion. So 10 to the power 2 into 10 to the power 11. Now imagine, there are 200 billion of galaxies also. So possibility, what happens, if you do the probability, there will be very high probability of life to exist. So personally, I believe, again, believing is not a option in science. But I think, I'm very polite, very way, life do exist elsewhere, but our capacity is not sufficient to detect those life. Intelligent life may exist somewhere. They may be, or we are the first civilized, first intelligent life to develop into cosmic communicating, because it took 4 billion years for us to become cosmic communicating life. So it may happen, but because of the distance, because of the the lack of sufficient advancement, either they are not reaching to us, or we are not reaching to us, or they are intentionally not reaching to us. There are many things. These are all speculation. So we should not delve into all those things. The thing is that so far we have not got any signal, any signature from anywhere that can tell that the biological reaction, the biological activities exist in any other places. We have to search them out. But not getting also makes our art is a very rarest and rare, very great object. So great that maybe we are alone. So we have to protect our planet first of all, because we have no place to go. So the first and foremost is that here is life, protect it. Now you know black hole, you know star, you know supernova, you know dark matter, dark energy, so many wonderful things. But you know, I think that art is the most wonderful object in the whole universe, because the divine phenomena, life exists here.
Good afternoon, sir. I am also from the same study. So I have a question that means what exactly the role means atmospheric pressure plays a role in determining the habitable temperature in habitable zones or habitable planets?
A very good question. So this boiling point, so habitable zone means the water under what condition, means thermal condition, water exists in liquid state. So we know that water exists in liquid state in 0 degree to 100 degree because of the pressure. The pressure is 1 atmospheric pressure. So some places like Jupiter, like Mars, that atmospheric pressure is very low. So there the boiling point of water will be much higher. Water will evaporate. The liquid water will evaporate under that small pressure. So it needs much lower, higher temperature for water to exist in liquid form. So therefore pressure is also an important thing. And actually the thing is that this pressure and this, all those things, we can define it from the surface gravity of the planet, that how much will be the pressure, and from there we can make out that what will be the temperature. But that's why we are directly going to detect the biosignature instead of determining whether the planet is habitable or not. The only one criteria we are now considering for the habitability, whether it is rocky and whether it is in the habitable zone of the star by the energy emitted by the star. So what is the brightness or what is the power of the star? How far is the planet from the star? From that we are determining what is the should be the temperature and whether it is rocky or not from its mean density, and then we are targeting the biosignature on those type of planets.
We had one question from the demo room. There was a request by a junior audience.
Which colleague?
Can we take the question from the remote location, please?
Sir, myself Sonepat from Gormali Arsiman Institution. So my question, can I say in Bengali, sir?
Yes, sure.
Sir, আমরা জানি আলো হচ্ছে এই মহাবিশ্বের সবচেয়ে বেশি বেগ, এর চেয়ে বেশি বেগ অ্যাচিভ করা সম্ভব নয়। আলোর চেয়ে বেশি বেগে কোথাও যাওয়া একটা কজালিটিভ প্রিন্সিপালকে ব্রেক হচ্ছে, তো এবং আইনস্টাইন থিওরি ওটা বলছে। So sir, my question is, if sir our Earth will destroy very soon, then we use warp drive technology, as it says, we can cross to place in just a few times, which is greater than light.
I'm not sure if I understood the question. Anybody understood it? But it's telling that the velocity of light, of course, velocity of light is just limit. You cannot exceed it because the laws of physics are same everywhere. So Einstein laws will be valid everywhere. So what you are telling that if the Earth is destroyed, then what will be happen? I could not understand properly.
The Earth will destroy.
একটু কোশ্চেনটা একটু আস্তে আস্তে বলো, ধীরে ধীরে বলো।
স্যার, পৃথিবী যদি খুবই হয়তো অদূর ভবিষ্যতে যদি ধ্বংস হয়ে যায়, তাহলে মানুষ কি ওই ওয়ার্প ড্রাইভ টেকনোলজিটা ইউজ করতে পারে? একটা দুটো একটা
ওয়ার্প টেকনোলজি কি টেকনোলজি?
ওয়ার্প ড্রাইভ টেকনোলজি।
আমি সেটা শুনিনি, সেটা সায়েন্স ফিকশনই আছে বোধহয় নাকি, ওয়ার্ক মানে ভেলোসিটি অফ লাইট এর এটা কি ঠিক নয় স্যার? যদি আর্থ এখন ডেস্ট্রয় হয়, এখন এই মুহূর্তে কোথাও যাওয়ার জায়গা নেই তার। এখন
যদি কোনো প্লেস ফাউন্ড করা যায় এবং খুব দ্রুতই ওখানে যেতে হয়, তো এই টেকনোলজি কি ইউজ করা যাবে?
না, এসব কিছু এখন ইউজ করা যাবে না। তুমি সিগন্যাল পাঠাতে পারো, তুমি নিজে যেতে পারো না। So whatever be the thing, as Carl Sagan has told that traveling is possible in near future, migration is impossible in near future. So it is better we protect our own planet instead of thinking of going somewhere else.
Thank you, sir.
নমস্কার স্যার। স্যার আমি শিয়াপুর গার্লস হাই স্কুল থেকে বলছি। আপনাকে আর BITM কর্তৃপক্ষকে ধন্যবাদ জানাই এই লেকচারটা অ্যারেঞ্জ করার জন্য। আমি জানতে চাই যে কার্টিসের স্কেল, যে এটা জানি আমরা সিভিলাইজেশন 1, 2, ওইটা কিরকমভাবে আমাদের ইন্টেলিজেন্ট স্পিসিসকে খুঁজে পাওয়ার জন্য হেল্প করতে পারে?
Effect of Google search. So Kardashev was a Russian scientist. So he has categorized Kardashev. I mean, বাংলাতে উত্তর দেবো না ইংরেজিতে উত্তরটা দেবো? আচ্ছা, Kardashev যেটা বলে যায় যে যদি সিভিলাইজেশন থাকে, যদি ইন্টেলিজেন্ট সিভিলাইজেশন থাকে, তাহলে তারা কতটা অ্যাডভান্স তার একটা স্কেল দিয়ে গেছিল। সেই স্কেলটা ডিপেন্ড করে যে সিভিলাইজেশন কতটা এনার্জি হারনেস করে বা কতটা এনার্জি সে ব্যবহার করে। সো যদি কোনো সিভিলাইজেশন তার উপরে আর তার প্ল্যানেটের উপরে, যেমন ধরো মনে করো আর্থ, যতটা সানলাইট সে পাচ্ছে তার পুরো সোলার এনার্জিটাকে যে ব্যবহার করে নেয়, তাহলে সে হচ্ছে সিভিলাইজেশন 1, টাইপ 1 সিভিলাইজেশন। তার মানে সেটা প্রায় হচ্ছে 10 to the power 18 ওয়াট বা 10 to the power 18 ওয়াটের মতো এনার্জি, যেটা সূর্য থেকে আমাদের এখানে এসে পৌঁছাচ্ছে। আর যদি কোনো সিভিলাইজেশন সে পুরো সূর্যটাই যতটা এনার্জি তৈরি করছে, তার আমরা একটা জাস্ট বিলিয়ন পার্টস আমরা এখানে পাচ্ছি, তার সূর্যটার কাছে গিয়ে একটা বড় সোলার বানিয়ে ডাইসন স্পেয়ার বলে, সেটা দিয়ে পুরো সোলার এনার্জিটাকেই এক্সপ্লয়েট করে নিতে পারছে। তারা হচ্ছে টাইপ 2 সিভিলাইজেশন। তাদের এনার্জি রিকোয়ারমেন্টটা এত বেশি যে পুরো সানটা যা পুরো স্টারটা যে এনার্জি প্রডিউস করছে সেটাকে ইউজ করতে পারে তারা। ক্যাটাগরি 3, টাইপ 3 হচ্ছে যারা এত বেশি অ্যাডভান্স যে পুরো গ্যালাক্সিটা যত এনার্জি প্রডিউস হচ্ছে, 200 বিলিয়ন স্টার প্রডিউস করছে, সেই এনার্জিটাকে তারা ইউজ করতে পারে। এরপরে ওটাকে এক্সটেন্ড করা হয়েছিল, কেউ বলেছিল যে টাইপ 4 বলে একরকম থাকতে পারে, যারা পুরো ইউনিভার্সটাকে নিয়ে খেলা করতে পারে, মানে অনেকটা ভগবানের মতো। কিন্তু ব্যাপারটা হচ্ছে যে আর্থে এখন যা আমরা এনার্জি প্রডিউস করছি বা এনার্জি ইউজ করছি, সেই অনুযায়ী যদি আমরা এক্সট্রাপোলেট করি, তাহলে আর্থ কিন্তু টাইপ 1 সিভিলাইজেশনও নেই, কারণ এটা হবে তাহলে 0.76, লেস দেন 1। তো আমরা এখনো ফসিল ফুয়েল ব্যবহার করছি, আমরা এখনো নিউক্লিয়ার ফিউশন এনার্জিকে কন্ট্রোল করতে পারিনি, আমরা এখনো সোলার এনার্জি সবকটাকে ইউজ করতে পারিনি, সেই জন্য আমরা এখনো টাইপ 1 সিভিলাইজেশনে যাইনি। তো আমার যেটা মনে হয় যে টাইপ 2 সিভিলাইজেশন পর্যন্ত একটা সিভিলাইজেশন যেতে পারে, কিন্তু যত সিভিলাইজেশন অ্যাডভান্স করছে তার ডিস্ট্রাকশন পাওয়ারটাও বেড়ে যাচ্ছে। আমাদের ডিস্ট্রাকশন পাওয়ারটা বেড়ে গেছে। আমরা হিরোশিমা নাগাসাকিতে একটা কিলো টন বোম ফাটিয়েছিলাম, আর এখন আমাদের মেগাটন, হাজার বোম, আমাদের ক্যাপাসিটিটা আমরা মানে এক মুহূর্তের মধ্যে পৃথিবীকে 10 বার ধ্বংস করে দিতে পারি। তো সেই ক্যাপাসিটিটাও বেড়ে যাবে, অ্যাক্সিডেন্টাল প্রবাবিলিটিটাও বেড়ে যাবে। কারণ যখন আমরা টাইপ 2 থেকে টাইপ 3 যাবো, তার আগে নিজেদেরকে ডিস্ট্রয় করে ফেলতে পারি। সেই জন্য টাইপ 2, 3 হয়তো এক্সিস্ট করতে পারে না। তো কার্ডাসেভ এইভাবে ডিফাইন করেছিল সিভিলাইজেশনটাকে, আর সেই অনুযায়ী আমরা এখনো টাইপ 1 সিভিলাইজেশন হই।
Good afternoon, sir. So, I am from St. Xavier's Institution, Ruya. Sir, here. So, as we all know that every day we are sending more and more signals in the outer space in order to find an exoplanet or any other extraterrestrial being. So, you said that we are evolving our technologies day by day and we don't know what will happen in next 100 years or 200 years. So, sir, should we wait for the evolution of technology and then send the signals, or do as we are already doing, sending signals each day and day by day?
See, we do not know how advanced is the technology, the alien technology we are searching. These are all speculative things. So actually you are not sending it. It is going on. If you use a mobile phone, that is also going to the space. So all the things, because the longer wavelength get blocked only by the ionosphere, all other signal like TV, radio, all FM radio, all those things penetrate the Earth atmosphere. So if some intelligent fellow comes, they search for the habitable planet, they will actually get the Earth is the most radio loud planet in the solar system. Because the stars are very weak radio source, the sun is very weak radio source. But because of this artificial radiation, Earth is very hot in radio. It's a very radio loud signal. Now the thing is that we do not know what type of thing. We automatically it are going on. So if some intelligent life are searching for us, it will find out Earth is very radio loud, and then it will find out that this wavelength and this periodicity and all those things are very abnormal. This cannot occur in nature. So naturally they will find out that there is intelligent life sitting here. Now it is up to them to decide what they will do. They want to come here or they want to keep us alone and they don't want to get disturbed. Sir, here you have a question now.
No, unfortunately that is all the time. In fact, we have exceeded the time. Thank you so much for illustrating all the questions that we had among the students. And a big round of applause for Sir, please, for his patient hearing. May I now request Professor Suman Sengupta, Treasurer, Royal Society of Chemistry, Eastern India Section, to conclude today's session by proposing the vote of thanks.
First of all, I should not say a lecture, it was almost like taking us to the interstellar space. It was a journey together, and it actually, this type of deliberation actually ignited our curiosity and courage to know about the interstellar space, because it's so huge and so big that we become very negligible there. So thank you, sir, for the deliberation, which will give us more courage to know. I would like to thank Professor Sengupta for this deliberation. His time is very busy traveling, but he made time to come to BITM and gave us this igniting lecture. I would like to thank BITM for supporting us in organizing this as a collaborator. The Royal Society of Chemistry Eastern Region heartfully thanks BITM and its members, Aditi Ghosh and others. They are actually instrumental in making these type of programs very successful. You can also see there are remote participations, and we are trying to bring these type of lectures to a bigger audience every day. I would like to thank the ex-executive members of Royal Society of Chemistry Eastern Region, Professor Ashish De, and all the advisors, and also the current president and secretary for supporting us in organizing this type of programs. With that, I would thank you all for your participation. The students, I would expect that you understood and got a lot of insight from this lecture, and the teachers and others who are present here. Thank you.
Thank you. Schools, please remember you're given a coupon, so you can show that in our ground floor.